a lot of the process you go through to refine oil, a lot of the variables or a lot of the things that you test for when making sure that the fuel that you produce complies with the specification are actually not being tested for, because the specification for jet fuel is a very stringent specification. But for example, the specification for newer types of fuels, these synthesized hydrocarbons that are coming from biomass, from other types of material, have a much more stringent, in order for them to be accepted into the community, they put up a much more stringent set of tests and things to look for in that fuel to make sure that it would comply with the original specification. The theory, and I really don't have any data to support this, but the theory is that if you would put one of these fuels that is produced from the heavier crudes through the testing that a biofuel has to pass, it probably wouldn't pass, right? And so, what's happening is that a lot of these fuels are making their way into the distribution system, and you're getting fuels that are compliant with the specification, albeit just barely, and they are, compared to a biofuel at least, less energy intensive, and so you fly. If you use a biofuel, you can fly further, and they're less pure in many ways, and so that's really the only thing that I can.
Yeah, well, it definitely seemed like an issue for Darren and Boeing, and it's the first I'd heard of it. And also.
You should probably ask them.
Yes, but
our research is really focused on biofuels.
Yep. And so getting to the Halophyte biofuel that you're working on, so I mean, it was very exciting. If I remember correctly, the hope was sort of that it might be in commercial production by 2017 if all went well. That's correct. So right now you're in the process of the first test site, right? Or
well, no, actually, we're in the process. So the whole question that was posed by the partners in the consortium was, can we scale this, and can we scale this sustainably? So that's the bottom line. All biofuels, the technology is there to convert them, and so there's no testing to be done. In terms of the chemistry of the fuel, there's really no testing to be done. There is testing to be done, and you have to go through a process that is already established through the governing bodies of this type of fuel, ASTM or DEFSTAN in Europe or in the UK. But basically, what happens is that you need to any biofuel, any fuel that is coming from biomass. The biggest question is it scalable? And we're at the Abu Dhabi ascent, right? And we're talking about deforestation. We're talking about the kinds of emissions that are produced by agriculture. So all these questions are going to come into play because biofuels are biomass. They come from biomass, and they come from the exact same place that our food comes from. And so if you are producing biomass, you're always going to fall into this debate of whether you're fuel or food. What we are doing is that we're moving away from that debate because we're not using fresh water and we're not using arable land. And so the basic question that we're trying to answer is scale.
How can you do it cost effectively?
Of course. And sustainability has three dimensions, right? The economic dimension. If it's not cost effective, forget it. Right? If it's not environmentally sound, forget it. And if it has a good social component to it, perfect. Right?
And there's also a component here with using waste from aquaculture, right, for the fertilizer.
Correct. And so part of what draws attention to what we're doing is that aquaculture grows at about a rate of 6% per year. Today we're 7 billion people in the planet. By 2050, estimates from the UN say that it will be anywhere between 8.1 and 10.6. Probably towards the higher of that range is going to be where we finally get in 2050. But how are we going to feed that extra 30% of the population and that 40% estimates range and say that about 40% of the world's population today is undernourished. Undernourished in what way? Basically that they're not getting their basic protein requirements in their diet. How are we going to cover that? Well, a lot of people are turning to aquaculture because aquaculture is really the only way you're going to be able to close that gap. There's only so much space on Earth left to have more cattle, to have more livestock in general, poultry, beef.
Yeah, and the emissions from all of them is a big issue.
Well, and I can tell you, aquaculture is not free of environmental problems, and actually, aquaculture has extremely bad environmental effects if not done properly. You can see it all over the world. I come from Mexico, and in northwest Mexico, you can see huge extensions of land, huge, tens of thousands of hectares, being dedicated to aquaculture, and all the effluent that's coming out of those farms is going directly into the Sea of Cortez. So this is a huge environmental problem that we're not even paying attention to.
Yeah, I'm not even seeing press about that.
And so this problem is going to increase. And so we need ways of filtering that water so that we can reuse it and not increase the environmental problems associated with aquaculture, or for that matter, with the production of biofuels.
And so there's the actual waste from that is what you guys use for fertilizer?
Correct, because it's as if, it's basically the same as you would use manure on ground-based agriculture. It's the same thing here. It's fish waste that goes into the water. The water that is used to irrigate the halophyte plantation has they become nutrients in this case, and the plants use those nutrients to grow. And so the plants benefit from those nutrients. The water is in a way filtered, and then the water can return to the ocean in a much better state than it would otherwise after the aquaculture operation.